All right, in this question it says, in the triangle ABC, the measurement of B is 90 degrees. BC is 16, AC is 20, and then they say there's another triangle, DEF, that's similar to triangle AB, where the vertices DEF correspond to these vertices. So basically I'm going to do this. A is D, B is E, C is F. So we don't have to deal with two triangles because they correspond equally. And each side of DEF is 1/3 of the length of the corresponding triangle ABC. What is the value of sine F? Okay, sine F is here. Okay, sine F. We know that sine is, when we do SOHCAHTOA, we know this is sine. It equals the opposite over the hypotenuse. All right? Now, before we get into this, I want to teach you guys something really cool that I am 100% guaranteeing you will use on any type of 90-degree question that has to do with sides, not angles. Okay? So let me take a little break from this question, and I want to teach you guys this real quick. We have learned special right triangles. When it comes to angles, we have 45, 45, 90. Then we have 30, 60, 90. You guys remember those? Okay? But these are the ones that deal with angles. There are other special right triangles that deal with sides. And you've learned the long way before. If you know what A is and B is, how do you find what C is? A squared plus B squared equals C squared. That's one way. So this one has to do with angles. This one has to do with sides. Okay? Now, there's another way to do special right triangles. And this is one of the coolest things. I have to just give props to my teacher, Miss Sobiek, back in the days when she taught geometry honors, okay? She taught that there are 3 different right triangles, okay? It's 3, 4, 5, 6, 8, 10, 5, 12, 13. And the Princeton Review actually teaches this. And it is one way, surefire way, to give you guys an easy way out of these questions, okay? So for example, these are 3 different types of 90-degree triangles, okay? You might have a question that does this. That gives you this, okay? A 12 and a 20. I can guarantee you that if you just in your head go, can I reduce this by something? Oh, both of them are divisible by 2. So divide by 2, that'll give you 10. This will give you 6, and you're like, oh, duh, 6, 8, 10. So this one would be 8. Since we divided these by 2, then you know that this one's going to be multiplied by 2. This one is going to be what? 16. And then you could find the third side. Do you guys get that? It's a super amazing rule that you guys need to use. I'm going to do some more examples right here, okay? Let's do the, I've seen an SAT math problem that did this. Find out what's this side. What can you start dividing it by? 2. So if you divide it by 2, what would you get? 12, 13. Oh, duh. 5, 12, 13. Right? So this side would be 5, but that's like the base of the number, but what would the actual side be then? 10. Do you guys see that? It's a very cool way of doing this. So anyway, using that same rule, 3, 4, 5, 6, 8, 10, 5, 12, 13. I used to make my students chant this in class until they got it down. Okay? So, we already know we're dealing with this triangle right here. We need to find this side. What can we divide each one of these by? 4. If I divide it by 4, it's going to yield me 4 here, 5. Oh, which one are we using, everyone? 3, 4, 5. So 3 would be like the original, like the base of the type of triangle. We multiplied every one by 4 because this one was divided by 4. So what is this actual side worth, everyone? 12. Okay, so now all they want to do is find the sine of this angle. Sine is the opposite, which is 12, over the hypotenuse, which is 20. And that boils down to, take out a 4, 3 over 5.